Welcome to Feature Fridays. My name is Guy Bartram. I'm Director of Product Marketing for our cloud providers here at VMware. And today we're going to be talking about Tanzu Application Catalog. And I just want to introduce Ryan. Ryan, thank you very much for joining. Why don't you just start off by giving a brief introduction about yourself, what you do, and who you are.
Yeah, sure. Thanks, Guy. My name is Ryan Baker. I am a technical marketing architect for VMware Tanzu, specifically focused on the VMware Tanzu Application Platform. So my role and responsibility is to create a lot of awesome content for our application platform, to really showcase the features that the platform can do and get to show them off to cool audiences such as this one. So really excited to be here and appreciate the invite to share the application platform with you.
No worries. Well, this is a relatively new solution that's come to our cloud provider portfolio. So I'm sure there's a lot of kind of questions about what it is, how it behaves. So let's just kind of take it from the top and work our way down.
Yeah, sure. Absolutely. That'd be fantastic. So I've got a whole slide deck here that I'd like to go through. It's got a ton of really great information on what it is and the problems that we're trying to address. So I think that'll kind of hit a lot of our points that we're interested in. So let's go ahead and dive into that. The Tanzu Application Platform is a new platform that we just released back in January. We had a follow-up release in early April with 1.1, and it had a lot of really super awesome features that I'm really excited to share with you today. Really kind of made the experience a lot better. So, but let's talk a little bit about what the Tanzu Application Platform is. So we have our tagline here, and it's basically a superior multi-cloud developer experience in Kubernetes. So let's break that down a little bit. So the first part that I always like to focus on is the superior multi-cloud experience, right? So what does that mean? So what we're trying to do with the Tanzu Application Platform is abstract developers and operators away from the complexities of multi-cloud environments, right? So Kubernetes does that to an extent, but even with inside of Kubernetes, when you're running them on multiple clouds, you can get a lot of different variances. And we don't want developers and operators to really care about that. So we want them to focus on developing good applications, new features, awesome content, those type of things, rather than the complexities of multi-cloud and Kubernetes. Sure. The second part about that is the developer experience, right? So we all know that developers really care about being productive. And when we think about Kubernetes and the applications that they're building, the more complex they are, the more it's pulling away the developers and operators from delivering awesome applications. So we want to provide a simple, easy to use experience. It's extracting developers away from the complexities of Kubernetes.
Okay.
So kind of to talk about a little bit about this, what I'm going to do is I'm going to talk about the developer experience crisis that we're going through, kind of set up the problem that we're trying to address with the Tanzu Application Platform. Once I've set those problems up, we'll talk about the Tanzu Application Platform itself, introduce it, and discuss how we're addressing those challenges that we see in the developer experience crisis. And then finally, over and over, and every time I do this presentation and talk with people, the feedback that I always get is that the demo really ties everything together. So I'm going to try to get through these first couple slides as fast as possible and get into the demo, because I think that really will help everybody understand exactly what the Tanzu Application Platform is doing and how it's helping solve that developer crisis.
Sure.
All right. So I've spent the last 6 or 7 years working with developers, whether it's in a DevOps role or a platform engineer or one of those type of roles where you're really interfacing with developers who are building new applications a lot. And the one thing that I have gotten from developers over and over and over again is that they care about productivity. And we're not just talking about the lines of code that they're writing, right? That's one simple measurement. But really what developers want to do is deliver awesome features. They want to make their products better. They want to make companies successful. So that's just some evidence that I've personally seen, but we also see a lot of studies. In this slide, we're talking about the McKinsey study that has shown a direct relationship between the developer velocity and the success of the company, right? So companies with higher developer velocities typically have faster revenue growth, and they're a lot more innovative. So we have information that shows us that better developer experience and better developer productivity directly relates to the success of a company.
It's sorry, just to interrupt, the developer velocity. What is that? What is the developer velocity index all about?
Yeah, so that's essentially how productive a developer can be. How much are they able to implement new features, new applications, rather than spending time on things that are not contributing to a company's mission. If that's, for an example, writing thousands of lines of YAML just to get an application up and running in Kubernetes. Those are things that are not contributing to a company's value, right? It's not making their product any better.
Sure. Okay, that makes sense.
So that's the premise, right? But the bad news is developers aren't really happy. The platforms that we're building to run applications and software itself is getting increasingly more complicated, right? And that's, again, pulling them away from that core value of writing awesome applications and getting new features out there. So we need to start to think about how are we going to simplify things for developers and operators. So introducing Kubernetes, right? Everybody knows what Kubernetes is. Everybody's adopting it. Our recent surveys have showed, we've gone from 59% to 65% of companies that we've surveyed have at least one application running in Kubernetes in production, which is awesome, right? For a new technology like that to come in and really start to get a ton of workloads. But it's not all fun and games. We talk to customers all the time that are having problems and experiencing challenges with Kubernetes. And two of the ones that that are kind of near and dear to my heart are, not surprisingly, the two that we see consistently in the top of our list of our survey, and that's around lack of experience and expertise in Kubernetes itself. It's a very complicated platform. There's a lot of what I like to call nerd knobs, that you can turn to make applications run better or run consistently. And so it really takes a lot of experience, and companies are challenged right now with hiring the talent and uplifting their operators and developers to be able to adjust to that complexity. The second item is really around security and compliance, right? So something I'm very, very passionate about is getting code from source code to a running URL or a running application as fast as possible. What I loathe, though, is doing that in a way that leaves the front door open to bad guys, right? Like that's something that we simply cannot do. So Kubernetes has changed the game, right? A lot of companies have very good practices and things in place in order to make sure that the software that they deliver is secure. But Kubernetes has kind of changed that game, and cloud native applications has changed it in a way that we got to rethink a lot of those things, because a lot of our old controls just simply won't apply or need to be adjusted in order to fit into a cloud native world. All right, so we talked a little bit about Kubernetes itself, but why is Kubernetes itself so complex? Why is it drawing away from that core tenet of producing awesome applications? I'm sure a lot of people have seen this slide before, or this image before, but for those who haven't, this is simply the amount of platforms or plugins or what have you that you can put into Kubernetes. It's the Cloud Native Foundation's list of all of the platforms that are available for Kubernetes, and as an operator to go through and try to select what you need from this diagram is overwhelming, and you can spend a significant amount of time just trying to get a Kubernetes platform up and running that's going to deliver your applications like you want to. So again, this is something that is really driving our operators away from of the core tenet of producing awesome applications.
Yeah, I love that chart. That chart is just like the epitome of complexity.
It's overwhelming, right? So I exited the operator role about a year and a half ago. And at that time, this chart was, I don't know, 3/4, half of the size. So just to watch it continue to grow is, I don't know how we can expect anybody to run a Kubernetes application like this. It's insane.
Yeah, sure.
Okay, cool. So we talked a little bit about the complexity of the platform itself. Let's talk about actually getting a application up and running in Kubernetes. So for anybody who has done that before, that there could be thousands of lines of YAML. So typically when you get started, you got to containerize your application. And this is one of the things that I really like to dive into, because I'm going to show in a little bit how the Tanzu Application Platform can help here. So a lot of times when people start containerizing their applications, the first thing they do is they start writing a Docker file, right? To take their application, put it into containers so that we can throw it out onto Kubernetes. Docker files can be really simple. They can be 5 lines of code like the one you see here. But when you start thinking about things like patch management, making sure all your vulnerabilities are taken care of, ensuring that the services are running in a secure configuration or best practice configuration, so your performance is what you expect, those can start to drive the complexity of those Docker files up. I've seen them go from simple 5 lines of code for a hello world Docker file all the way to hundreds, if not multiple hundreds of lines of code. So again, just an example of things that developers are spending their time on that isn't really providing value to the company. So now that you've containerized your application, you need to start thinking about, how am I going to run it in Kubernetes? And there's a ton of things you need to think about. We've got some of them listed here, routing, scaling, eventing, how are you going to configure the deployment for the replica sets and role-based access? How am I going to expose it to the world through an ingress? Again, going back to that multi-cloud thing, like how are we going to make it portable across all the different cloud providers and all the different Kubernetes providers? So these are all things that you need to think about when you're building the configuration for Kubernetes on how to run the application out there. And again, I'll show it in the demo here, but I mean, this can easily become 3,000 lines of code just that quick, which is, unfortunately, sometimes more than your application or your service itself, which is, you got to stop and think about that and realize, like, I'm spending more lines of code running my application than I am building it, which can be problematic.
Sure.
All right, cool. So we've built our application. We've defined how to run it. Now let's talk about that path to production, right? So every organization has some sort of path to production. So how do I get that code from source code to URL? And what's the processes that I need to go through? Some companies have really awesome paths to productions, and some companies not so much, right? Everybody's somewhere in between. But none of them are the same. Everybody has their unique path to production, whether it includes, vulnerability scanning or some sort of continuous integration testing. Everybody has their path to production. And what we see a lot of is paths to productions are typically defined at a per application level, right? So you have an application and you build it and deploy it. It's got a path to production. But then we have another application that we kind of tweak it and modify it. And, so you end up with a ton of these little code or pipelines that are unique per application. It just becomes a real big pain to scale. So how do we address that? And what are we doing with the Tanzu Application Platform? All right, so perfect time, right? Time to introduce. I've talked about all these problems. Let's talk about what the Tanzu Application Platform is and how we're addressing these. And there's 3 big bullet points, and I'm going to hit these just ever so highly. And then I'm going to talk about, as we go into the demo, I'm going to talk about each one of these and talk about how we're actually addressing it with the Tanzu Application Platform. And I think that'll really kind of to illustrate it better. So the very first thing we talked about, huge focus, is unlock developer productivity. How do we ensure that developers are able to build their application and iterate on it quickly, easily, and without having to deal with all the toil that Kubernetes introduces? Second one, build a rapidable yet sustainable path to production, right? So we think about continuous deployment pipelines. We think about how we get that code into production. We want to simplify all that. And that's what the Tanzu Application Platform is going to focus on. We're going to have a single supply chain or a couple of supply chains that our applications can map to, and they're application aware. So they're going to identify what type of application this is and build the configuration and build the supply chain to get that code into production based off of the type of application. Finally, we need to coordinate the work between dev and ops, right? So we all know DevOps culture. We know that it's successful. We know that it's awesome, but there's still a lot of throw it over the wall mentality that's going on, right? So developers will build an application, throw it over the wall to operations team. And the operations team might try to run a vulnerability scan on it and find out that there's 5-10 critical vulnerabilities, throw it back to the operation or to the development team, tell them to fix it. And there's just a lot of back and forth that really does not promote a good culture. So as we walk through this, I'll kind of talk about, like, how are we ensuring that we're developing or that we're providing a platform that promotes a successful handoff from dev to ops.
Okay.
All right, so let's dive into how we do this. So one of the core tenets that we have in the Tanzu Application Platform is a clear line of delineation between our dev and our ops or our SecOps teams, right? So how do we do that? We focus on providing what we call an inner loop for our developers and an outer loop for our operators. So in the inner loop, we talk about things like allowing the developers to have an environment where they can learn it, right? How do they get started? How do they onboard, do workshops, those type of things in order to get them up to speed quickly? Once up to speed, ready to develop, how do we give them boilerplates, starter templates for applications that include application code that's already been defined by roles such as your enterprise architects, your software architects, security, operations, those type of things. Give them a boilerplate to get started rather than starting from scratch that includes all of the best practices that my organization has defined, right? We'll go through those here in a second. Mm-hmm. Once they have a boilerplate, how do we allow them to quickly iterate on the application? So I'll talk about that. I'll show you how we can build an application, deploy it to Kubernetes, and then iterate on it very quickly, very rapidly, so the developer gets quick feedback on the changes that they're making. And finally, debug. We won't touch on this one today, but we provide plugins to IDEs in order to ensure that they're able to debug quickly and easily in a running Kubernetes environment. And then finally, moving over to the ops side, this is where we define reusable supply chains, and I'll dive really deep into this one. But just know this is where the operators live. This is where they define supply chains in order to get that code from source code to URL.
Okay.
All right, Cool. So I made it through all of the fun slides, and I'm finally to the point where I get to demo. And this is my most favorite part of this. So I'm going to hop into a couple things, and I just promised that we'd be done with slides, but more slides is always fun. So just real quickly on what we're going to do on the demo. So I'm going to build and deploy a Spring Sensors application, and I'm going to do this from two perspectives. The first perspective I'm going to do is focus on inner loop, right? So I'm going to assume a dev persona. I'm going to act like I'm a developer. I'm going to walk through exactly how we would get started with the Tanzu Application Platform. Once I've completed building my application, I'm going to hop out to our outer loop, and I'm going to play the role of an operator. I'm going to show how we can take that source code and get it deployed out to production, and then have that supply chain in there so that any future changes to the application will automatically get deployed. All right, so this is a little bit more detailed slide than the one that we went through, but it's one that I like to go through because it really kind of sets up the demo well. So in the first part, I'm going to spend my time as a developer, and I'm going to go through our inner loop workflow. I'm going to start out by using our app accelerator. So I'm going to pull down an app accelerator template that's basically just a boilerplate, like I mentioned, to get me started with my new application. I'm going to pull that down. I'm going to iterate through that application. So I'm going to show how I pull it down, and then I'm going to iterate, modify some code, get it deployed to a live Kubernetes environment so we can actually see exactly what's going on. And then finally, like I said, I'm not going to show the debug today, but just know that it's out there and it's available. And if you wanted to set breakpoints on your code and debug it, you certainly could. It takes a little bit of time, and I want to make sure we get focused on the outer loop as well. So we'll talk about it, but we won't necessarily demo it today. Okay, so let's hop out here and let's get started. So I'm going to hop into our application platform's GUI, which is based on Backstage and something that we're very, very excited about, and we've gotten a lot of great feedback about. So I talked about application accelerators. Let's go ahead and hop into and discuss what those are. So as I go into the application accelerator page, you can see I've got a list of accelerators here, and I think it's an even number. So let's just say that there's 10 of them. But these are ones that we provide out of box, and these are by no means what we expect all of our customers to use. These are just simply templates that we give out of box to get them started. So you can see there's multiple languages, multiple application types. But again, these are ones that they're just defined in YAML, so we can allow customers to modify them, adjust them to how they see fit, or create entirely new ones and bake in their best practices. So I said we're going to build a Spring Sensors application. So let's go ahead and dive into this accelerator. So I'm going to choose this accelerator. You can see once I choose it, I have a lot of options. These options are basically just filling out our templates from that boilerplate of the application. These can be as simple or as complex as you want. Again, they're all modifiable. I've seen tons of accelerators that customers have built that are insanely awesome, right? They've got a ton of options and really allows their developers to flex based on what they want to do. So I'm just going to choose all the basics here, basic, names, GitHub repository the code's coming from, and then where to publish the Docker image. So I'm going to go ahead and go to generate accelerator, and this is building a zip file that I'm going to download and start iterating on in my IDE. But before we do that, let's go ahead and explore the zip file. There's a couple things that I want to show here. So the primary thing that I want to show is the configuration. And this is the workload.yaml. And this is really kind of the heart and the soul of how we abstract developers and operators from the complexities of Kubernetes. You can see that we have 19 lines of code here in this workload.yaml. This is all that it's going to take to get that application up and running in the Tanzu Application Platform. We do that by a couple ways. So the first thing we have is a workload type here that is defining the type of workload that our application is. So we have a web here. This is what's going to match it to our supply chain. So this is going to be our supply chain for web applications, which in a customer world might be pretty rigorous, right? Because if you're going to make something internet facing, you're going to want to go through, a high level of security vulnerability testing to make sure that we have no critical vulnerabilities in the application before it hits the internet. We're going to make sure that it's tested to make sure that we're not exposing something to the customer that has bugs in it. So it might be a little bit more rigorous supply chain that we want to go through. The other part is the Spring Sensor. So it's labeling the application to what part of it is. That's going to help us see it in the top GUI. The other cool thing here is that we're doing a service claim, right? So if you have some sort of backing and persistent state that you want to maintain your application in, you can bind it to a service so that you can use that backing stream.
So Ryan, these accelerators, is this something that you imagine customers to create? Well, obviously customers can create them for their own kind of usage, but is this something like a cloud provider can provide additional value to the customer and deliver accelerators for them?
Absolutely, yeah. I would think it'd be one of the primary ways that they could deliver value, right? So And if you've got the platform, you can add on additional, workload types and supply chains. And so the really cool thing about supply chain, which I'll talk about when we get to the operator side, is supply chains are entirely modular. They're entirely customizable. So if a cloud provider has services that they wanted to expose as part of their supply chain, absolutely, just put it in as one of the modules on the supply chain and allow, if it's vulnerability scanning or, some sort of tooling, we can just add that in, and that would be a huge value add.
Yeah, got it. Okay.
All right, cool. So I've downloaded that. Let's go ahead and hop out to my IDE. So I'm running Visual Studio Code here, and you can see I've downloaded the application code. So this is the accelerator. It's got all of the code to help us get started from the application accelerator. And let's just go ahead and take a look at this. So I've got just a simple application, Tanzu Sensors Database. What I'm going to do now is I'm going to iterate on it. And the way I can do this is I can just do a Tanzu live update start. And what this is going to do here in the background is it's actually going to kick off our developer supply chain. In the background, you're going to see it kind of start to fly here through a second. But for a few minutes here, it's going to build a container. It's going to build a container using the Tanzu build service, which we're going to talk about here in a little bit. But it's the way that we're abstracting developers from having to write that Docker file. So you can see in here, there is no Docker file defined for our application. We're dynamically building the containers using cloud native build packs, which I'll talk about here in a second. But so what's going on now is in the background, it's building that container image, and it's going to push it out to what we like to refer to as our personalized development or development environment, or our personal development environment. So what that is it's basically just a Kubernetes cluster, right? And this could be, in my example here, I'm running it out in the cloud, but it could be something local, like Kind or Minikube. And we all know that developers love to work local. So we want to certainly make sure that we are giving them the option to run Kubernetes locally. And what does this mean, right? So this is nice because we're actually running the application in Kubernetes. We're not using something like Docker Compose or just running it natively locally. And that really helps develop and push that relationship between dev and ops, because they're developing in an environment that is going to be very consistent to what they're going to be running in production, right? This is not Docker Compose, which, trust me, I have fought many times. Like, we deploy an application out, it doesn't work, we're trying to figure out why, and it's because some inconsistency from when the developer was building it using Docker Compose where we're running in Kubernetes. And those are typically the hardest and most complex problems to try to figure out. So by promoting a consistent environment all the way across the development lifecycle, you're going to help mitigate a lot of those issues. Okay, so this is building. And it's running. It'll be done here just in a second. We can see that it's just building all the layers for the image, assembling them, pushing it up to my Docker registry. And again, we'll go through this a little bit more in depth here once we get to the outer loop. We'll have a little bit more time to walk through it. But again, what this is going to do is it's going to build it, push to the registry, and then it's going to run it in my Kubernetes environment. So if I just hop out here and I just do a kubectl get pods. This is, again, my development environment. So this is my personal development cluster. You can see that we have a build pod running, and it's pushing out configuration. And in just a second, we're going to have the application up and running. Yep. So
Okay.
Let me come back here. And as soon as I see that it's waiting to listen on the port, then we should be good to go. And one thing I want to point out here, because this is taking a little bit of time, this is only going to take time on the first run. So we've got to build that container image and get it pushed out and the configuration built and all that stuff. Once we actually start iterating on our code, you're going to see it's super fast. So while this is taking a second to get started, it's only on that initial live update start. Okay, so we have successfully launched our application. So you can see I'm just localhost 8080. And it's important to point out, because I've had quite a few questions here, that it says you're in a remote cluster. Why are you localhost? In the background, we're just doing a port forward, just in case your remote cluster has doesn't have an ingress or something to that effect. We're making it so that it's accessible. So that's why it's localhost. Yeah. So now our application is up and running. So let's go make a change and see how that looks. On my screen. Sorry for the back and forth here. So let's come over here and let's just change the title of the application. And then I'm going to go ahead and save it. And when I save it, you're going to see the build process get kicked off. And now what it's doing here is it's not actually rebuilding that entire container image. We're using Tilt to basically inject the modified files directly into that container. So it's going to greatly accelerate the development process. You can see by the time I flipped over, it's already updated. So this is just one way that we're integrating our plugins into the IDE to allow a developer to iterate very quickly and see those changes very rapidly. And the most important part, it's running in a Kubernetes environment that's going to be very similar to what they're running on in production. This is running on top of TAP. It's a lightweight installation of TAP so that it can give the developers a quick and easy way to get started. But again, promoting consistency between dev and prod.
That's really nice, and that's going to save so much time. Just to set all this stuff up to start with is quite a mammoth task. So having this out of the box is brilliant.
Yeah, absolutely. Yeah. And it's one thing, every time I demo this, I see developers being like, oh, this is amazing. Developers don't enjoy going back and forth with the ops either, trying to find these silly issues that are from development and environment differences. So yeah, something everybody's very excited about. I always get lots of clapping when I do this. So very excited to show that. So, okay, cool. So that's just a quick look on the inner loop, and I can sit there and I can iterate, over and over and over again on that. But once I've finished building that application, this is where we really kind of draw the line between the inner loop and the outer loop. And that's when developer has finished developing their local application. They're ready to actually get it, pushed out into production or have it running in a real environment. So we typically draw that line of delineation at the check-in of code or merge standpoint. So if it's a pull request, it's merge. If it's an initial application, we talk about the check-in. And that's where the outer loop comes into play. So the outer loop, as I mentioned previously, is where our operators and our security teams focus at. This is where they build the supply chains in order to promote the code from source to URL and do it in a way that matches the patterns for organizations. So a lot of organizations that we talk with already have a path to production that they've set up. It could include things like doing continuous integration tests or building containers if they haven't been built already. Security things such as scanning the images for any vulnerabilities or signing them before pushing them to the registry. And then obviously, as part of that, you have to deploy the application and then run it. Within the Tanzu Application Platform, we run our applications on cloud native runtimes, which is Knative. So it also gives you access to a lot of cloud native deployment patterns, which I'll go through in some of the demo.
Okay.
So that's the outer loop. That's where the security and operations teams define the supply chains in order to get code from source to URL in a repeatable and secure manner, right? So let's talk about these. So in the Tanzu Application Platform, we have 3 supply chains that come out of box. The first of these is a simple basic source to URL. So essentially all that supply chain is doing is taking your source code and deploying it to a running application. The second supply chain that we have is a sourced and test to URL. So it includes the building of the container image, deploying it, but it also includes continuous integration tests. So we include a testing feature in that. The third and the final one, which is the one that I'm going to demo today, is our test and scan supply chain. And this is the supply chain that we see matches a lot of organizations in what they're using. So it's the one that we like to demo. So in this supply chain, we pull down the source code and we do a test of it initially. So we'll pull down the source code, we'll test using continuous integration with Tecton. Mm-hmm. After it's tested by the Tecton supply chain, we will then move into a scan. So what will happen is we'll pull the source code down, we'll scan the source code for any vulnerabilities. And if it doesn't have any vulnerabilities that exceed our scan policy, we'll allow it to continue. If it does have vulnerabilities that exceed our scan policy, we'll stop the supply chain right there. By doing so, we're shifting left security further into the development process and deployment process. So we're preventing vulnerabilities from getting into production before they even have a chance to get there. So we're moving from a reactive model to a proactive model and making sure that front door is always staying closed.
Yep.
After we've scanned the source code, we'll use the Tanzu build service to build the container image. And I'll dive into this quite a bit in the demo and talk about how we're able to build it using the Tanzu build service and abstracting developers and operators away from using Docker files by using cloud native build packs. Once we've built and pushed the container image up to our registry, we'll then pull that image back down and do a scan on it for any vulnerabilities. So rather the source code, we're actually scanning the resulting container image for any vulnerabilities. Again, checking against our scan policy to ensure that there are no vulnerabilities that exceed our scan policy requirements. Finally, we're going to run it. And as I mentioned earlier, we're going to build configuration, and I'll go into this in more detail in the demo, but we'll build a configuration to take that container image that we've built, generate the configuration for Kubernetes, deploy it out to cloud native runtimes, and really take advantage of a lot of the cloud native deployment models. So I've talked a lot about the supply chain and talked about the bits and the components that are part of the supply chain. One thing I like to mention here is a core tenet of the Tanzu Application Platform is to provide the supply chains to be modular. So I mentioned Tecton, I mentioned Gripe, I mentioned Tanzu Build Service. These are all tools that we provide out of box. It's VMware's opinion on how to get started. It gives you a really good getting started point to see a supply chain functional out of box. But that doesn't mean that's what you have to use. We have a lot of customers that have, existing continuous integration testings like Jenkins or, different scan tools. And we want to make sure that we're allowing customers to use those investments that they already have. So we've created supply chains that are modular in nature. So if you have Jenkins already, you can swap out Tecton and use Jenkins. It's really up to the customer. We want to meet them where they are so that they're not having to rebuild a bunch of stuff in order to use the Tanzu Application Platform.
That's great. Mm-hmm.
Cool. So that's our supply chain. So let's go ahead and hop out to the demo and see how this works. So let's move over here. And so I am on our production cluster. So you can see I'm on tap demo. And I am essentially just going to create a workload. So let's do that. Let's do a Tanzu app workload create config workload.yaml. And this, oops, forgot my dash F. So this workload.yaml file is going to look very familiar. This is the exact one that we have out of the accelerator with one change, and I'd like to point that out. So we have a label that we've added here, which basically is a has test label. And all this is doing is telling the supply chain like, hey, I have continuous integration tests. Go ahead and run those as part of the supply chain. Okay. So let's go ahead and create the workload. And let's hop back out to our GUI. So if we come into here, we can see our workload visualization, and let's go ahead and dive into Spring Sensors, and we can see that it's starting to run. So what you're seeing here is it's set up the source. So it's established our Git repository as our source for our code, and then it's kicked off the source tester. So it's pulling our source code down and it's testing it for any vulnerabilities. Let's hop out to Kubernetes and let's take a look at what is going on here. So if I just take a look at the pods, I'm just going to do a klogs, and I'm going to follow the logs on this. We're going to see that it's downloading all of the application code and it's building it, and then it's going to run the integration tests that are supplied by Maven. So this is going to take a minute here to run. It's going to take a minute to download it, build the application, and then run the tests. And we'll see here that the developer has created some awesome tests. So we have one integration test that we're going to run, but it's all in the name of speed. So we're going to run through that. And then as soon as it passes, it'll move on to the next step of the supply chain. And while we do this, this is a good pause point for any questions if you had any, Guy. I know we've gone through quite a bit here pretty quickly.
Yeah. So. I mean, so from my perspective, I'm looking at this, I'm trying to think like a cloud provider can offer this entire solution to a customer now, and they can go and fill their boots, right, and start doing their testing or whatever they want to do in terms of their release cycles. But also the cloud provider could provide specialization. They could start working with those supply chains, recommending supply chains, building the tests for the customer according to their best practices. So really helping customers with their kind of new application development, but also doing that from a kind of a highly sustainable manner, really, because you can scale this out pretty easily across many customers very quickly just by reusing those supply chains, right?
Yeah, absolutely. Yeah. I mean, that's one of the core tenets is we want those supply chains to be both modular and reusable, right? So if you define it for one customer, certainly could take that supply chain and reuse it for another customer as well.
Yeah, sure.
Yeah, okay. Couldn't have said it better myself.
I'm learning.
There we go. Great. Okay, cool. So we have we've passed the source test. If you saw there, we had one test that ran. There was no failure, so we continued on. The next step they did was a source scan. So let's just take a look at that. Let's do a K source scan, K get source scan, and we can see that the source scan has completed and didn't find any vulnerabilities that exceeded our scan policy. This one ran really quick. I'll take a look at the image scan policy later, and we'll dive a little bit deeper into how all of that works. Okay. So the next step you can see is we've started off of a container image build. So I like to take a look at this one because it gives us a really good view into exactly how the Tanzu build service works, and kind of elaborates on how we can abstract developers and operators from having to maintain and build Docker files. So let's walk through this. So I'm looking at the logs of the container build, and we can see here that we're going through a couple phases. The first phase is a prepare, where we're just pulling down the source code and getting all of the secrets set up so that we can access that source code in the repositories to push our final image to. The next couple steps are analyze, detect, and restore. So on the detect phase, this is the one we really want to dive into. And you can see that we have 23 build packs that are participating. So basically what this is we have 23 build packs that we're leveraging. And each one of those build packs has a signature in them. So that signature is then executed against our source code to determine if that build pack is applicable. So you can see we have 10 out of the 23 build packs that are participating in this container build. And we know that our image or that our application is a Spring Boot application. So the signature is matched on it being Spring Boot. It's an Apache Tomcat being served by that. And we're also using Maven. So it's starting to identify how our application is developed. And it's going to build our container image using cloud native build packs. And the important thing to note about this is that these cloud native build packs are maintained by the community. They're used in things like Heroku and Cloud Foundry. So they're very well established by the community. So it's helping your developers not have to worry about maintaining best practices in secure or in container images, making sure that patches and vulnerabilities are taken care of. We're leveraging the community to do that and allowing developers and operators to focus on driving value to the business.
And that's not just a specific Tanzu community thing, right? We're talking about the whole community as a whole, right?
Yeah, correctly. Yeah. Those cloud native build packs are the entire community. Yeah. So we're leveraging the entire open source community for that. That is not a Tanzu specific community. Okay, cool. So let's go ahead and take a look. The build should be almost complete by now, if not complete. Yeah.
And
cool.
Ryan, just to interrupt there. So if I didn't want to use like open source config and I wanted to use my own build packs for my own repositories, I could also use those in this respect.
Yeah, absolutely. Yeah, you can build your own build packs. We have customers that are doing that today to inject specific configurations that they want in their images. Yeah.
Okay, cool.
Okay, cool. So we can see that the image has finished building. We're reusing layers here because I've built this image before, so it's pulling some of those layers from cache since they haven't been modified to speed up the build process. We've pushed the image to my container registry. And one thing I like to point out here is that we're also pushing a signature. So we've signed that container image and we've pushed it up to the registry with our container image. And the reason that this is important is the Tanzu Application Platform has an admission webhook in it that you can enable to prevent any unsigned container images from running in your environment. So if you want to make sure that every image that you're running has an authentic source, that's how you would want to do it. So we want to make sure that the images that we're building as well are also signed.
Yeah, sure.
Cool. Okay, so now our container image is built. Let's go ahead and see where we're at. So we can see our entire supply chain has finished. So let's kind of walk through these last couple steps. So the next step is an image scan. So as I mentioned earlier, we're going to pull that image down and we're going to scan it for vulnerabilities. So let's go ahead and take a look at how that looks. Let's do a kget image scan. And we're going to see that we have scanned it and it's completed successfully. There are 0 critical vulnerabilities, 0 high vulnerabilities. So we're passing our scan policy. And I've mentioned that a couple times, but let's go ahead and take a look at what that actually is. So let's take a look at that. And one thing that I like to point out here while I'm going through this is that you notice that these are all Kubernetes primitive resources, right? So everything is defined as a resource in Kubernetes, which makes it really nice. You don't have to worry about, an additional data store or configuration that's strewn out all over the place. It's all right in your Kubernetes cluster.
Yeah.
Okay, so we can see here's our scan policy. And basically, this is the line I like to point out. So this is what we've defined as our violating severities. So if we had any vulnerability that was found in our application that was higher, that matched these vulnerabilities, it would stop the supply chain right there. I'd say, nope, can't continue on. You've got vulnerabilities that exceed our policy, our organization's policy. Fix those, and then we'll let that application get delivered through. So as I mentioned, we had no critical, no high vulnerabilities. So our application was allowed to dive in. Now, one of the things that we also do is we send this data off to our metadata store. So if you want to look at it in a better view or get more details about it, we can certainly do that. So let's do a kget image scan here. And I'm going to grab the SHA here because that's how we're going to look it up. And I am going to do a Tanzu insight image get -- digest. Oops. Digest. And so we're going to pull this up and you can see that we have a list of all of the packages that were found in that container image and then all of the vulnerabilities that are part of those packages. So you can get a real granular view here. And this is sent off to an archive data store so we can look at this over time as well. Conversely, if I wanted to know my exposure to a specific vulnerability, so let's say I was really concerned about this core utils vulnerability, I could search on that as well and pull back all of the container images that have been built and pushed to our metadata store that have that vulnerability in it.
No, that's really useful. Yeah.
Very useful. Yeah. I certainly wish that when I was kind of going through operations, I would have had, that kind of tool to help me out. It would have slept better at night for sure. Okay, so the last couple steps here are config provider, app config, and config writer. So these are kind of interesting to dive into. What these are actually doing is when we built the image with the Tanzu build service, we attached a bill of materials to that image. So the Tanzu build service from the Cloud Native build packs knew exactly what it was putting into that image. It attached that bill of materials to it so that we could use it later in the process. Mm-hmm. And this is where being app aware really comes into play as part of our supply chains. So what's happening now is our config writer or our config provider and app config is taking a look at that bill of materials, and it's identifying the Kubernetes configurations that should be assembled in order to match the application that's being built, right? So we know it was a Spring Boot. So Spring Boot's an easy one. We can talk about that. So it's a Spring Boot application. So it's going to it has Spring Boot actuators on it, which we know is going to provide, health check endpoints. So by knowing that that's part of the bill of materials, we can automatically generate the readiness liveness probes that get attached to the application for Kubernetes. So we can automatically detect when the application is healthy, when it should be terminated, when it's ready to serve requests, all of that stuff. And normally that's stuff that your developers and your operators have to configure manually and require some background knowledge. But we're doing that all as part of the supply chain. So it's automatically generated for you.
And where's that stuff configured? So it knows about this. Is there a library store somewhere?
Yeah, it's all in the configuration of Kubernetes. So there's Kubernetes resources out there that are that you can look at, you can modify. They're all, again, just Kubernetes resources that you're able to take a look at. So okay, cool. So the other part that I like to point out here is the config conventions. So what conventions are is think of them as like global conventions, basically, that you like to apply, that your operators would like to apply to the application. So the example that I like to use is the observability tools. Observability tools usually have annotations or labels that they like to have applied to all of the running containers so that it knows how to inspect them for, metrics, or that it should inspect them for metrics. So what we do is we provide conventions that allow operators to define and create conventions and then apply those either globally or to a subset of the applications based off of labels. So that just allows a control point for operators to inject additional configuration into Kubernetes. Okay, so our application has been tested, scanned, image has been built, scanned again, and configuration is built. We've deployed it out to Kubernetes. So let's go ahead and take a look at that. So let's hop over to our Spring Sensors application. This is the catalog entry in Backstage for it. You can see that I have a running instance of it. So let's go ahead and dive into that. And I can get a whole bunch of information about the metadata here. Ooh, actually, let me go back one step because we can see here. So from here, I can go out to source code. If I had tech docs defined, I could view the tech docs for it. And the same as if I had APIs configured for that endpoint, we'd be able to browse those as well. Okay. Well, let's go into the actual runtime resource now, and let's take a look at this. So we can get all sorts of awesome metadata about the application, its status. If you come down, you can see the annotations label. So just a lot of really good, rich metadata about it. But we can also see things like the routes. So if I had multiple routes defined, you'd see them here. You can also go directly to each route with a link to it. We also have revisions. So if I were to modify my application, commit the code, supply chain would kick off again. And then I would see a second revision pop up here. And you would see traffic shifting from 0 to 100%. So you can see kind of that load balancing pattern going on there. So now let's go ahead and go back up and let's launch our application. And we can see here that as we launch it, there's a slight pause here. And what's happening is in the background, that request is going into Cloud Native runtimes, and it's holding that request because it doesn't have any pods available. But in the background, it's spinning a pod up. And as soon as our readiness probe says that the application is ready, it's going to release that request and send it all the way through to our application. So you can see now that our application is up, request has been sent through, and just to prove it, if I sit here and click refresh, it's going to be instantaneous. So that little delay there was just literally waiting for that pod to become available as it scaled up. So, okay. And now's a good time too. So we've set up this initial supply chain. We've run through it once, if I was a developer and I was going to go back in and commit code, now that we've set it up already, it's going to automatically kick that supply chain off, and there's not going to be any involvement from an operations or security team. That supply chain is set up. It's going to be reusable, go through all of our defined policies, and it's going to continue over and over. So your operations and security teams are just completely out of the way at this point, not in the way of developers anymore. And that's what everybody wants, right?
Yeah, absolutely.
Yeah, so that pretty much wraps it up for the demo.
So as just to bring it kind of into the cloud provider context a little bit, Ryan. So from a cloud provider's perspective, this is a solution that they would kind of deploy in their premise, offer out to cloud to customers within their cloud environments on-prem. Either perhaps deploy it for a customer in their environment in maybe a private cloud, or also kind of give it to multiple customers. Does it support that level of kind of customer access and tenancy?
Yeah, absolutely. Yeah. So, I mean, it's fully deployable. I mean, it can, our goal is, as long as you have a compliant Kubernetes environment, we're going to run tap on it. Or we're going to support having tap running on it. So, that's the whole goal. And yeah, absolutely. It doesn't matter if it's on-prem, in the cloud, wherever, you're going to be getting a tap deployment that's consistent. So, yep.
And how do customers authenticate to this service that we're looking at now?
Yeah, so the UI has a bunch of different authentication modules in place. I just have it set up for guest, but it's got several different options for providing authentication. And we also have a pretty robust set of RBAC features set up in place. So all the personas that we've talked about, whether it's developers or operators, we already have a predefined set of RBAC policies for those users so that you can get started out of box. And obviously you can manipulate those as you see fit. They're, again, just like everything else, they're just Kubernetes resources in the background. So if you want to modify them, maintain them, it's totally up to the customer.
Awesome. Well, man, this has been a great demo. I've really, it's the first time I've seen this. So for me, it's been a real education. And from what I can see, this is going to make life a lot easier for the entire kind of end-to-end, from developer all the way to operations. You're literally taking a lot of the repetition. I remember doing this like a few years ago and taking all those tasks you had to do in terms of getting the operations and security correct. You're just automating the whole lot. It's just beautiful supply chain, fully automated.
Yeah, absolutely. Yeah, no, as I said, I've spent 6-7 years prior to coming to VMware in the DevOps role, and I wish I would have had something like this. It just would have, I would have slept a lot better at night, because I'm out of the way of developers. Nobody wants to make a developer angry. Or make them wait. So, and knowing that applications are getting deployed in a secure and repeatable manner, I just it excited me. I'm so excited to be part of this and to be able to show it to everybody.
Yeah, it's great. It's some cool tech, and it's going to make a big difference for our cloud providers to offer this to their customers, and for the customers to kind of realize the benefits of either the cloud provider's managed service or cloud providers kind of input into the supply chain and testing and best practices, and securing those environments as well. So I think there's a lot of value and synergy that we could, our cloud providers can deliver to to their end customers. Ryan, listen, man, thank you very much for your time. It's been really cool to talk to you, and I really appreciate you running me through the Tanzu Application Platform. Thanks a lot.
Yeah, absolutely. Thank you, Guy. I really appreciate the time. You have a good one.